Hi, my name is Tracy Brackenbach. I'm going to discuss how to use an algebra balance to solve equations. I don't have an algebra balance, so we're going to use this online application to kind of get an idea of how they work. I've already gone ahead and put my initial equation in here. We start simple. So the equation is x minus 4 equals 5. And I'm going to show you how to set this up. So what you do is you start by building your left side. So x and then minus 4. So you're going to grab these little balloons here, and you can kind of imagine, that the balloons are pulling up the x. So I'm going to put 4 over here. So now this is x minus 4. So our left side's done. Now on the right side, it's going to equal 5. So if I stack up 5 blocks here, we should balance out. Okay, and there it did. And that just shows you that you set your equation up correctly. Uh, and what you're going to do next is, just as if you were doing this on paper, we're going to add 4 to each side. And so if I put 4 over here, then I also have to put 4 over here. Okay, so now I've balanced out once again. But as you can see, we have what's called a zero pairs over here, since the negatives and the positives cancel out. So I'm going to go ahead and just take these away one by one. And as I do, you can see that we still balance when I take each pair away. Okay, so now we've gotten rid of all those. What we're left with is x is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So x equals 9, and that's the finished product. But you can also do this algebraically by going here to continue. The two sides don't match the equation. Oh, I see. I have to reset this up to do the equation algebraically. So let me go ahead. X minus 4. Okay, so that's our equation as we started. So if I go to continue, you can do it this way as well, and it's a lot quicker, but you don't get to play around with it and actually get hands-on. So I'm going to add 4 to each side just like I did with the balloons. Okay, and it just gives you the answer, x is equal to 9. So it's the same thing, um, but really it just does it for you. So if you know what you're doing and you're adding your 4 to each side, it will do it for you, but you don't get to play around with it and really visualize. So that's basically how this program works. We're going to go ahead and do a little bit harder equation. So I'm going to go 2x plus 4 is equal to 8. And okay, so there's our equation. So 2x, so plus 4, so I need my blocks here. 1, 2, 3, 4 is equal to 8. So I got to stack 8 over here. Okay, now we balance out. So this is our equation. Uh, again, your next step would be to subtract 4 from each side. Um, so remember, whatever you do to one side, you have to do the other. So if I subtract 4 from the left side, I also have to do the same to the right to balance it out. And that's kind of how the algebra balance can show you that you have to do the same to both sides. And again, we have zero pairs here. So we're going to match these up and get rid of them one by one. And this takes a little while, but you know, it really shows you you know you're affecting the equation when you're taking away um, from each side. You know, and so we're still balanced now that we've done that. I have my x's here on the left, and I have 4 here on the right. Now, as you can see, I have 2 x's and 4 ones over here. Um, and to get this just to x equals a number, you're going to have to take away an x. If you take away 2 here, it should balance out because 2 divided by, or 4 divided by 2, since I had 2 x's, would be 2. So x is equal to 2. Again, we're going to go ahead and set this up just to do the problem algebraically. So I'm going to add all this back in. So that's at 2x plus 4 over there. Okay, so now we've got our problem set up. I'm going to go ahead and click continue. And so if you remember, we subtracted 4 from each side. So I'm going to go to subtraction, say 4, and see it went ahead and took away the 4 from each side. Now here again we have 2 x's and 4 over here. So if you're doing this on paper, you divide by 2 to get just 1x. So if we do that, you get x is equal to 2. So same thing we did, it's just a little quicker, and they do all the work for you. So we're going to do a little bit harder problem now. Let's go 2x plus 3 is equal to 4x. I actually want to make this minus 3. Okay, so here's our equation. So over here on the left I have 2x plus 3. Now on the right I'm going to have 4x and minus 3. So you're going to use the balloons for the minus again. So 1, 2, 3. Okay, so now we balance out. Now I want to get my x's on one side. Um, so I'm going to subtract 2x from the left side and 2x from the right. And you could really just throw these away. That's one way of doing it. But just so you can see these little balloons in work, we're going to go ahead and use them. So 1, 2. So I subtracted 2x from the left side. So I'm going to have to do the same over here. Okay, now we balance out. And again, we have 0 pairs of x's this time. So if I throw these away, okay, so now we balance out again, and now I have isolated my x's on the right side of the equation. Now we have just 2x over here. Now I want to take away or add 3 to each side to isolate the x's again. So I'm just going to add 3 over here. Now if I did it on the right, I have to do it on the left. So I'm going to add 3 over here. And again, we balance out, but we have 0 pairs, so we got to get rid of these. So now what I'm left with is 2x on the right side and 6 here on the left. Now again, I have more than one x, so we're going to need to do a little division. We have 2 x's and 6, so the answer is going to be 3, because 6 divided by 2 is 3. So if I go ahead and just throw one of these out and get rid of 3 of these, we should balance out again. So there's your answer. X is equal to 3. I'm gonna set this up again just to show you how you would do this algebraically. So 2x plus 3, that's our left side. So we're going to do 4x over here minus 3. So that's where, gets back to where we started. So I'm going to go to subtraction, and if you remember, we subtracted 2x to begin with. So subtract 2x, there they go. And then we're going to add 3 to each side, so go. And that leaves us with 2x, or 6 is equal to 2x. And again, we did the division last, so if you divide by 2, you should get the answer x is equal to 3, which is what we did. And so that's a little more complicated. You have, x's on each side of the equation. And I think we're going to go ahead and do one more. Let's see, let's do a negative 1x plus 9, and then 3x. I don't even know if you can do this. I'm going to try minus x. No, you can't do that. Okay. Let's say minus 2. Hopefully that comes out good. Let's see. Okay, so that's not going to come out right. Let's do, I don't know, is that going to be 3? Would that work? Okay. So let's try this. We have a negative x over here, so negative x plus 9. Ooh, this could take a while. Okay, so that's our left side. Negative x plus 9 is equal to 3x minus 3. Okay, so we balance out. I want to get all my x's on one side. So I have a negative x over here. So I'm going to add an x to each side. Again, we have a 0 pair, so I'm going to throw these out. And now we balance. And now I need to add 3 to each side. So 1, 2, 3, 2, oop. Ooh, I think I ran out of space. Well, that's no good. Wonder if we'd let us do this just algebraically, because I can't stack any more over here. I guess I should have tried this before. But let me clear this out. I'm just going to start fresh here. And so, yeah, obviously there are limitations to this program. I think the reason why it's not letting me is because I'd have a double-digit number over here, which obviously doesn't like. How many do I have here? 1, 2, 3, 4, 5, 6, 7, 8. So one more. So negative x plus 9, 3x minus 3. See, I bet it won't even let us do it this way because of the limitations on this program, but we're going to try it anyway. So we're going to add x to each side. So I did that, and then we're going to add 3 to each side. Okay, so yeah, it's saying you can't add 3 because it's too big for the scale. So even though I kind of goofed this up, it's a good example of just some of the limitations of this program. Uh, but you get the idea. I wish I could have shown you this one here on the scale, but that's okay. I think you probably understand how to use the scales, and if you have the full size version in your classrooms, it's a really good tool for the kids to visualize and get a hands-on manipulative uh, to look at these equations a little differently. And also, highlights the rules of, if you're going to do something to one side, you have to do it to the other. And if they're not doing that, they can see how it's out of balance. And that's really cool. I think that this would be a great tool to use just to introduce algebraic equations in your classroom. So, all right, well, thank you very much, and I hope you enjoyed.